Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey is one of the farthest we've ever taken together, not just across stars or through time, but outward, toward the imagined edge of everything. What would happen, we'll ask, if you set out in one direction and simply never stopped? Would there be a wall, a boundary? Would space itself give way to something else, or to nothing at all? But before we settle into the vastness of that question, I'd love if you could take a moment to gently tap the like button and subscribe. Only if these sleepy little science stories help you feel more at home in the universe. And when you're ready, leave a comment to tell me where you're listening from and what time it is there. It's always a quiet wonder to see how this strange, soft conversation drifts across time zones, from twilight in Tokyo to midnight in Montreal, from stargazers in Sweden to night owls in Nairobi. Wherever you are, you're part of this gentle caravan of curiosity. Now, if the day has been long, if your mind feels cluttered or restless, don't worry. You don't need to remember everything we talk about tonight. In fact, I hope you won't. This isn't a lecture. It's a slow walk through the dark, a soft invitation to wonder, and if your thoughts begin to wander, that's perfectly fine. Let them drift. Like a feather caught on a breeze, they'll return if they want to, and if not, I'll still be here, patiently unfolding the story. So, find a comfortable place. Let your body sink into the mattress or the cushions or whatever quiet place you call your own. Maybe there's a fan humming softly, or the distant rustle of a tree outside your window. Let those sounds be part of this. Take a breath in, a little slower than usual, and then breathe out, like you're exhaling the weight of the whole day. Again, in and out. Good. Tonight we're going to explore a question that sounds simple but hides infinite complexity. What lies at the edge of the universe? It's a question that doesn't behave. It wiggles and shifts and sometimes disappears just when you think you've got hold of it. Because, and here's the strange part, we don't even know if the universe has an edge. And yet, we keep asking. Like a child pulling at the curtain in a darkened room, just to make sure there's nothing waiting behind it. We'll talk about light, how far it can go and why that distance forms the bubble we call the observable universe. We'll imagine building a ship, pointing it in a direction and letting it fly forever. We'll wonder whether, after enough time and speed, you might circle back around or slip into something else entirely. Along the way, we'll think about dimensions we cannot see, the shape of everything, and what it means to say something is infinite. And when the sky grows quiet near the end, we'll ask what it means for everything to grow so far apart that even light itself cannot keep up. There will be no abrupt jumps, no sudden explanations, just the slow expansion of thought, like ripples in still water, as we follow each question to its quiet edge. And before we begin, one last thing. The word universe can feel heavy, like a grand, impossible thing far beyond our reach. But for now, let's think of it more simply. Not as everything that exists, but as the space that holds you right now. Your breath, your heartbeat, the soft pressure of a blanket. A universe doesn't have to be endless to feel vast. Sometimes, the most infinite feeling comes from the smallest things. So let's begin. Let's set our little ship adrift on the sea of stars and start asking the oldest, softest question of all. What lies beyond? Let's begin our journey not with a bang, but with a breath. Tonight, as you lie there, perhaps tucked beneath a soft blanket or listening to the slow hum of a fan, try to picture the word universe. What does it look like in your mind? For some, it might be a swirl of stars. For others, a great black void with points of light suspended in the dark. Or maybe it's something abstract, a feeling of vastness, of mystery, of something quietly too big to hold. Whatever comes to you is enough. That's the beauty of it. The universe doesn't demand precision from your imagination, it just gently invites wonder. In scientific terms, the word universe refers to everything that exists: space, time, energy, matter, and even the rules those things follow. But tonight, we'll take a slightly softer view. We'll think of it not as a cold collection of particles and equations, but as a kind of expanding fabric, something that stretches out around you and continues on, beyond the reach of your senses, gently unfolding. Now, here's something curious. When you hear that the universe is expanding, you might picture galaxies flying away from each other through space, like glitter tossed into the wind. But that's not quite right. What's really happening is that space itself is expanding, not the objects within it rushing outward, but the very canvas of reality stretching in all directions. It's a quiet, subtle motion, not something you'd feel if you stretched out your arms or tried to measure it in your living room. But over cosmic distances, the effects are profound. Galaxies that were once close together are now millions or even billions of light years apart, not because they moved through space, but because space grew between them. Imagine baking a loaf of raisin bread. As the dough rises in the oven, the raisins don't move on their own. They simply drift apart as the dough expands. In this analogy, the raisins are galaxies, and the dough is space itself. You might say the universe is an ever-rising loaf, with everything inside growing more distant, not because of speed, but because of stretch. This leads us to one of the strangest yet most important realizations in modern cosmology. The universe has no centre. That's right. No middle, no anchor point, no cosmic bullseye from which everything is radiating. Because if all of space is stretching, then every point within it experiences the same expansion. It's not like a balloon where the air rushes out from one spot. It's more like a balloon inflating where every bit of the surface moves away from every other bit equally. In fact, that balloon is more than just a metaphor. It's a powerful way to think about how space behaves. Picture an ant walking on the surface of a balloon. To the ant, the surface is two-dimensional. It can move forward, backward, left, or right, but it can't climb up into the air above. As the balloon inflates, the ant sees all other ants getting farther away no matter which direction it looks. And if the balloon keeps expanding forever, the ant will never reach an edge. It'll just keep walking, always finding more balloon beneath its feet. We're like that ant, except in 3 dimensions, not 2. We can't easily see or feel the shape of the universe, but the mathematics tells us that it might behave in much the same way. The universe could be finite but unbounded, meaning it has no edge, no outside, but also doesn't go on forever in the way we imagine flat space does. And here's where it gets even stranger. Even though the universe is around 13.8 billion years old, the observable universe, the part we can actually see, is about 46.5 billion light years in radius. That might sound impossible. How can we see something farther away than the universe is old? The answer lies in the nature of expansion. While light has been travelling toward us for 13.8 billion years, the space it travelled through has been expanding that whole time. So the galaxies that sent out that light long ago are now far, far away. Their distance stretched by the cosmic dough around them. The light is just now arriving, but the source has moved on. What we're seeing then is a kind of light echo, a delayed image from a younger universe, caught in the act of growing. The farther we look, the farther back in time we go. And at the very edge of what we can see is the afterglow of the Big Bang itself, a faint, almost ghostly shimmer known as the cosmic microwave background. It's not an edge like a wall, you can't touch it and you can't go there, but it marks the farthest limit of what light has had time to reach us from. Beyond that boundary, the universe continues, maybe endlessly, maybe not. But for us, that light barrier is as far as our eyes, or our telescopes, can go. So here we are. a small point of awareness in a fabric that stretches in every direction. We float not at the centre of the universe, but in the middle of what we can see, surrounded by light from the past, drifting on an ocean of space that is quietly growing wider every moment. It's humbling, yes, but also deeply peaceful. Because even though the universe is vast beyond measure, it is also still, expanding, yes, changing, yes, but doing so in a way that's gentle, steady, and ancient. It's like a slow tide, not to be outrun, only noticed, and tonight you've noticed it. It's a strange thing to imagine, the edge of the universe. The phrase itself feels so final, like there's a fence somewhere, painted black and studded with stars, beyond which lies what exactly? A void? A wall? A great cosmic sign that reads no further? But the universe doesn't seem to play by those rules. It rarely provides answers in the form we expect. When we ask about its edge, the universe responds with silence and light. Because what we call the edge of the universe isn't a place in space, it's a limit in time. Let's step gently into that idea. You see, everything we know about the universe, every star we've studied, every galaxy we've catalogued, every distant glow we've tried to interpret, has come to us by way of a light. And light, for all its speed and elegance, still takes time to travel. When we look at a galaxy a billion light years away, we aren't seeing it as it is now. We're seeing it as it was a billion years ago because that's how long its light has taken to reach us. And so, the edge of the observable universe is not a boundary in space, but a kind of horizon in time. It marks the furthest distance from which light has had time to reach us since the beginning, since the moment the universe began to shine. Now here's the twist. The universe is approximately 13.8 billion years old. That might lead you to assume that the furthest we could see would be 13.8 billion light years. But because the universe has been expanding the entire time that light has been travelling, the actual distance to those furthest light sources right now in this moment is closer to 46.5 billion light years. It's a bit like watching someone walk away across a stretch of rubber. The moment they begin walking, the rubber also starts to stretch, and by the time their footsteps reach your ears, they're much farther away than their walking alone would account for. The sound, like the light, was delayed, stretched not just in distance, but in meaning. This edge, this shimmering horizon, is called the observable universe. And it's important to say that word, observable, because beyond that edge the universe almost certainly continues, but no signal from beyond that boundary has reached us yet. It's not that those regions don't exist, it's just that they lie beyond the reach of light itself. And until light arrives, they might as well be hidden behind a veil. At the very edge of visibility lies something even stranger, not galaxies, not stars, but a glow, a soft, uniform microwave hum that comes from every direction in the sky. It's called the cosmic microwave background, or CMB for short. And it's not just old, it's ancient. This light comes from a time just 380,000 years after the Big Bang, when the universe had cooled enough for atoms to form and for photons to travel freely. Before that, the cosmos was like a fogged window, hot, dense, and opaque. So when we look out at the edge, we're not looking at distant space, but at ancient time. We're seeing the baby picture of the universe, a moment when it became transparent for the first time and light was free to wander. Now, here's something subtle, but deeply important. That microwave glow, the CMB, is not something that sits in one direction. It surrounds us. It comes from everywhere. Because the Big Bang didn't happen in one place. It happened everywhere at once. Every point in space began expanding at the same time, and so every direction we look shows us a different ancient path that light has travelled to reach us. In this sense, the edge of the observable universe is like a shell, not a wall we could reach or touch, but a horizon of information, It's not a fence. It's a story that light is still telling, and it's a moving story. Because the universe is still expanding, the observable edge is always changing. New light from ever more distant places is arriving all the time. The sphere of the visible universe grows slightly larger each year, like a slow tide pushing further up the beach. And yet, paradoxically, many of the galaxies we see today have already passed beyond the point where their light will ever reach us again. Their final messages are en route, but once those arrive, we will never hear from them again. That's the quiet heartbreak of cosmic expansion. To see something so clearly and know that its voice is fading. So does the universe have an edge? Well, no, not in the way we imagine. There's no wall, no curtain, no outer shell of bricks or stars or mysterious matter. The universe might be infinite, or it might be finite but without a boundary, like the surface of a sphere where you can walk forever without falling off. But what we can talk about is the edge of what we can know, the horizon of observation, the place beyond which no signal has yet arrived. It's a kind of soft limit, one defined not by barriers, but by time and patience and the stretching of light across unimaginable distance. And so tonight, as you lie quietly and think about the sky above you, the stars you can see, and the countless more you cannot, remember that the edge isn't out there to be touched or crossed. It's something we listen for, something we wait on. A whisper in the dark, still making its way through space, still telling us stories from long ago. And when it arrives, we'll be here, watching, wondering, and listening. When we gaze out into the universe, what we're really doing is assembling a mosaic of old light. Each patch in the sky, each glowing smudge or spiralling galaxy, is a piece of time that has drifted toward us across a sea of expanding space. The farther out we look, the further back in time we peer. But as we've gently uncovered already, seeing is not the same as reaching. The universe, in its quiet vastness, isn't divided by fences or flags. But if we're careful, if we follow the rules of light, time and expansion, we can begin to outline different zones, each one stranger than the last. Not visible in the sky, of course, but written into the laws that guide motion, distance and causality. So let's imagine a gentle map, not drawn on paper, but unfolding in space, measured not in kilometres or miles, but in the fading echoes of light. Zone 1, the reachable universe. This is the universe you and I live in, not just in theory, but in practice. It's the region where we could, given enough time and ingenuity, go. If we built a spacecraft today, perhaps not with current technology, but with dreams stretched just slightly further, this is the part of the cosmos that still remains within our reach. Because of the universe's expansion, this reachable zone extends only to about 15 billion light-years in any direction. That's farther than any human or robot has travelled, of course, but still a small portion of what we can see with telescopes. Within this sphere, if we launched a ship travelling just below the speed of light, say 99.9%, and had the patience to wait, we could in principle reach any galaxy or star that resides here. The light from these regions reaches us, and, crucially, if we sent light back, it would reach them too. We're connected. Our actions, our messages, our movements still belong to the same cosmic stage. But just beyond this boundary, the rules begin to shift. Zone 2, the visible but unreachable. Between roughly 15 and 46.5 billion light-years, we enter a strange place. Here we can see the galaxies. Their light has reached us. Their images decorate our star charts and scientific papers. Some of them are majestic, great elliptical giants, crowded starbursts, delicate spirals caught in mid-collision. But we will never reach them. Why? Because space between us and them is expanding faster than we could ever hope to traverse. Even if we launched a spacecraft today, Even if we pushed it as close to the speed of light as physics allows, the gap would only widen. Light from those galaxies continues to stream toward us, but our ships and our messages will never arrive. They are in a sense ghosts, present in our skies, absent in our possibilities. This is one of the quiet tragedies of cosmic acceleration. Some of what we can see is already lost to us, like waves that roll toward the shore even as the ocean itself retreats. Zone 3, the not yet seen but inevitable from about 46.5 to 61 billion light years, we find a region that is still hidden, not because it doesn't exist, but because its light hasn't yet had time to reach us. These parts of the universe lie just beyond the edge of visibility, like islands on the far side of a dark sea. But unlike the visible unreachable zone, these regions will become visible one day. Not because we move toward them, but because their light, still in transit, is on its way. Imagine it like this. You're standing at night, watching distant fireworks from across a valley. You see the flash, and a few seconds later, you hear the boom. But there are some you haven't seen or heard yet, not because they didn't happen, but because their signals are still crossing the distance. In this zone, the light is coming. The images are forming. And one day, millions or billions of years from now, future astronomers, or whoever still listens to the sky, will witness new galaxies emerging into view. Galaxies that existed long ago. Their stories carried slowly on the back of photons. But just like the visible unreachable zone, this third region holds no possibility for interaction. Once their light has passed us, the rest will never follow. They are glimpses, not invitations. Zone 4, the forever invisible. And then, beyond it all lies the quietest region, the truly unreachable, the forever unseen. This part of the universe lies beyond 61 billion light years, and by all our current understanding, it will remain beyond our reach, not just physically, but observationally as well. The light from these distant corners has not reached us yet, and because of the way expansion is accelerating, it never will. Their stories will remain untold, their galaxies unnamed, their stars forever hidden. It is humbling to realize that most of the universe lies not in darkness, but in absence, not in what we cannot see, but in what we will never be able to see, no matter how long we wait or how powerful our telescopes become. Some call these zones causally disconnected. It's a quiet, clinical term, but it carries a profound truth. These regions cannot affect us, and we cannot affect them. They're outside our light cone, separated not by distance alone, but by the very fabric of space-time, and yet they're still part of the universe, still part of the same great unfolding. It's like living in one room of a vast house whose other rooms you'll never enter, but still knowing they exist, still feeling, in some strange way, that their presence matters. So tonight, when you think of the universe, don't picture it as a place you could walk across, or as something you might circle around. Instead, picture these zones like ripples in a pond, concentric spheres defined not by borders, but by light. Some ripples reach you, some never will. But all are part of the same water, and you, little voyager, are floating gently in the centre of what can be known. A still point in a growing story. By now you might be wondering, if we've mapped what we can see and what we can't, and even what we'll never reach, then surely somewhere there must be an end, a last galaxy, a final grain of light, a cosmic curtain behind which there is only black. It's a natural thought. After all, everything we know in daily life has edges. The room you're lying in has walls. A walk through a city eventually brings you to its limits. A loaf of bread has a crust. Even the sea, vast as it is, eventually gives way to shore. But space, real, physical space, doesn't seem to obey that kind of logic. And the deeper scientists have looked, the more gently and persistently the universe seems to whisper, "There may be no edge at all. Let's think slowly through what that means." Imagine first that the universe is infinite. It goes on forever, in every direction with no boundary and no repetition. That's a staggering idea. It means there's no final star, no outermost galaxy. Every time you think you've reached the end, you could keep going, and still never be halfway there. This idea is supported in part by the measurements we've made of the curvature of space. If the universe is infinite, then space is flat. Not curved like a ball or shaped like a saddle. Observations of the cosmic microwave background and large-scale structure suggest that space is incredibly close to flat. If it isn't flat, it must be curved so subtly that even light travelling billions of years hasn't been able to reveal the bend. But here's where things get more intriguing. Just because something looks flat doesn't mean it is infinite. Think of the surface of the Earth. To someone standing in a field, the ground appears flat. You can walk for hours without seeing it curve, but keep going long enough, and eventually you'll return to where you started. The Earth is finite, but it has no edge. You can walk forever, but you'll never fall off. That's because it's a surface that curves back on itself in a higher dimension. A two-dimensional space wrapped into a sphere. Now imagine for a moment that our three-dimensional space does something similar, curving gently in a higher dimensional realm we cannot perceive. In such a case, the universe could be finite, not infinite, but still without boundary. You could travel in one direction forever and never find a wall. You'd simply loop back around eventually to where you began, perhaps without ever realizing it. This idea isn't just science fiction. It's been explored seriously in cosmology, using the mathematics of topology. One possibility is that the universe is shaped like a three-torus, essentially a donut, but in 3 dimensions. If you move far enough in one direction, you might return from the other side, like a character in an old video game who exits the screen on the right and reappears on the left. There are even researchers who have looked for evidence of this in the sky, hunting for repeating patterns in the cosmic microwave background that might hint at light having circled the cosmos and arrived from multiple directions. So far, they haven't found definitive proof. But the idea remains, not ruled out, just quietly waiting. And this brings us to one of the most gentle, yet mind-bending truths about cosmology. We don't know the full shape of the universe. We see only a bubble, 46 billion light-years in every direction, and must guess what lies beyond. We're like ants in a room with fogged-up windows, trying to deduce the architecture from the patterns of echoing sound. It might be infinite. It might be curved. It might loop back on itself. It might even be part of something larger still, a patch in a quilt of universes stitched together in ways we cannot imagine. But here's a comforting thought. Whatever the shape of space may be, infinite or curved or unending in ways we cannot trace, you are already inside it. You don't need to cross it. You don't need to find the edge. You are already part of it, cradled by it, drifting gently within its unfolding geometry. And if one day we do discover the true shape, if some bold measurement reveals a gentle bend, or a whisper of curvature, or a repeating glow in the sky that confirms we live in a wrapped-up space, it won't make us smaller. It won't trap us. It will only deepen the poetry of where we are. Because to know the shape of the universe is, in some quiet way, to know the shape of everything, the stage upon which all time and matter unfold, and the soft boundary of what we can call here. So whether it loops or stretches, whether it bends or flattens forever, the universe holds no edge like a book or a page. It holds only questions and light, and the soft patience of stars still forming, galaxies still spinning, and space still expanding into whatever lies beyond. And you, as you breathe here tonight, are in the middle of it all. Not at the edge, not at the centre, just somewhere. And that's exactly enough. Let's imagine something quietly impossible. You're standing on a launch pad. The The stars above are still, the earth below gently humming with life. Before you is a ship, not of steel and fuel alone, but of thought. It's not burdened with buttons or blinking lights. It doesn't rely on the noisy push of rockets. This is a vessel built only from curiosity, driven by a desire to reach what cannot be touched, the edge of the universe. Of course, we know no such craft exists, not yet, but that's the beauty of a thought experiment. Tonight, in this soft corner of the cosmos, we can build whatever we need. So let's do something bold. Let's send this imaginary ship outward in a straight line at nearly the speed of light. Not all at once, that would be too sudden, too violent, but gradually, like a child, pushing a paper boat into a river and watching it drift beyond the reach of shore. The first thing you notice if you're aboard is the silence. Space doesn't roar. It doesn't whistle past you. There's no rushing wind or engine hum. Even at extreme speeds, 90%, 99%, even 99.9% of the speed of light, the ship simply glides. Because what you're moving through isn't air or water, it's a vacuum, an absence, a stillness. The stars remain in front of you, but they begin to blur, just slightly, toward the centre of your view. Light itself bends inward as you accelerate, not because it's changing, but because you are. Reaching these speeds is no small task. In reality, it would require unimaginable amounts of energy. The closer you get to the speed of light, the more resistance you encounter, not from space itself, but from the very nature of mass and motion. According to Einstein's theory of relativity, the faster you go, the more your mass increases, not in the way that you get heavier at the holidays, but in a deeper, more fundamental way. Energy becomes mass, and mass demands more energy to keep moving. It's a loop that nature refuses to let you break. At 90% the speed of light, your ship might already seem absurdly fast by human standards. You could reach the nearest star in under 5 years. At 99%, time would slow dramatically for you aboard the vessel. What feels like days inside might be decades outside. At 99.9%, this effect becomes even more intense. Your clocks tick almost normally from your perspective, but for the rest of the universe, your journey is stretching, not just in space, but in time. And then come the dangers, not dramatic or cinematic, but quiet and relentless. At such speeds, even a stray atom of hydrogen floating in the vacuum becomes a bullet. There's no air in space, but it's not truly empty. The ship's hull must be strong enough to deflect or absorb countless particles, each carrying energies that would vaporize metal at lower speeds. Shielding isn't optional. It's survival. And even then, there's radiation, the slow, persistent build-up of high-energy photons and cosmic rays. Every second of travel is a negotiation with the invisible. But let's say you manage it. The ship is launched. The shielding holds. You accelerate until your speed settles just shy of light itself. You point your nose toward the great unknown and you go. From Earth, people watch. At first your signal still reaches them, delayed, but there. Like a distant lighthouse blinking from across the waves. Scientists track your position. Children imagine where you are. But slowly, subtly, your connection begins to fade. Not because your transmitter fails, but because the space between is growing. You are moving forward, but space itself is stretching beneath your ship like a rubber sheet drawn gently in all directions. The farther you go, the harder it becomes for your signals to return. The photons you send home are caught in the expanding void. Their energy redshifted, stretched thinner with each passing light year. At a certain point, somewhere around 8.3 billion light years away, a line is crossed. Not a visible one, not marked by any sign, but a line written into the laws of causality. Beyond this threshold, space is expanding so quickly that no signal, no message, no flicker of light you send can ever reach the solar system again. You're now causally disconnected. You and Earth no longer share a future. It's a strange kind of loneliness, not the kind we feel on long nights or in empty rooms, but a structural loneliness, a quiet, cosmic break in what was once shared. You can still look back, you can still receive light, though increasingly faint and red. But Earth can no longer hear you. No telescope, no antenna, no clever trick of physics will bring your voice home again. From your perspective on the ship, nothing dramatic has happened. The stars continue to move. The universe still stretches out before you. But something irreversible has taken place. Not in your engines or your systems, but in the geometry of reality itself. And the farther you go, the more profound that separation becomes. You have left behind not just home, but the possibility of return, not because you went too far, but because space changed shape while you moved through it. The moment your ship slips beyond the boundary of return, beyond that invisible line where space expands faster than even light can chase, the journey changes. Not in motion, not in speed, but in meaning. You're no longer a traveller. You're something else now, a witness of solitude, drifting into a version of the universe that no longer includes a shared past or future with the place you came from. Earth becomes memory. Familiar stars shrink into relics. And even time, so firm and predictable in daily life, begins to behave differently. That's because you've now stepped deep into the domain of relativity. And relativity, unlike the intuitive physics of everyday objects, isn't kind to simple expectations. It's a realm of bending clocks, slowing pulses, and the quiet collapse of synchrony. Back home on Earth, time continues. Clocks tick forward. The moon tugs at oceans. Seasons change. But aboard the ship, your ship, something else unfolds. Let's say you're moving at 99.999% the speed of light, or just a hair beneath the cosmic speed limit. From your perspective inside the ship, you don't feel much different. You aren't crushed against your seat. You aren't aging faster. Everything seems normal inside. But if you glance at Earth's clocks, something startling reveals itself. Their hands are spinning wildly. A single hour on your vessel might correspond to weeks on Earth, or months, or centuries, depending on how fast you've gone and how long you've been moving. This is time dilation, a fundamental result of Einstein's special relativity. The faster you travel, the slower time passes for you relative to the outside universe. Not an illusion, not a glitch, a real, measurable change. Your heartbeat slows only in the eyes of others. To you, it still thumps its quiet rhythm, unaware of the world spinning past at relativistic pace. And the further you go, the greater the gap becomes. After a few decades aboard the ship, you might glance at your monitors and discover that thousands of years have passed on Earth. Cities may have crumbled, civilizations may have bloomed and faded. Perhaps no one remembers your departure. Perhaps they do. Perhaps new life has begun, with no knowledge of the quiet vessel still slicing through the dark. If you wait a little longer, a century too, the stars you once knew might be gone. Red dwarfs flickering out, solar systems swallowed by their aging stars. The sky becomes unfamiliar. Eventually you realise you're not only moving through space, you're leaping through time. This isn't science fiction, it's physics. If you could travel fast enough and for long enough, you could emerge into an age of the universe no one else has ever seen. An era so distant that galaxies are only faint blurs, red-shifted beyond recognition. An epoch where black holes have swallowed all light, and even they are beginning to fade. It's the ultimate solitude, not only separated by distance, but by time itself. And there is no going back. The universe doesn't care how fast you go. It only cares about light. Once you're past that threshold, that 8.3 billion light-year line, the expansion of space is now pulling the fabric apart faster than light can cross it. No return signal, no reversing course, no clever trick of navigation will bring you back across that gap. Because even if you turn around, space continues to stretch between you and home. It's not just that you're moving away, it's that space is growing under your feet. Relativity, in its quiet simplicity, allows this. It predicts this. And the universe obeys it without fuss, without drama. That's what makes it so eerie. We often imagine the speed of light as a barrier, a wall we cannot break, and it is. But in this case, the wall is not just in front of us. It's behind us too. Once crossed, the causal boundary becomes a prison with no doors, even if it looks just like the space you've always known. Still, from within the ship, nothing feels strange. You still breathe. You still drift. Time flows normally in your cabin, unaware of the universe sprinting forward around you. If you had a window, or a telescope, you might look back and see nothing but red. Light stretched thin by distance and time, flickering like embers at the edge of sight. Ahead, stars still twinkle. Not many, fewer than before. The universe is thinning, but it still stretches forward, offering motion even when meaning begins to fade. And in this silence, you begin to understand something subtle, that speed is not escape, that distance is not freedom. The farther you go, the more the universe reminds you that time, not space, is the true frontier. And time, once lost, cannot be retrieved. You're no longer of the same world you left, not because you were banished, but because you chose to chase the edge and found it wasn't a place, but a process. You didn't cross a wall, you drifted past a horizon made of time, and that, perhaps, is the most beautiful kind of distance, one that cannot be closed, only witnessed. If you could look out the window of this ship, this silent vessel that no longer shares time or causality with Earth, you might expect to see the familiar constellations, the graceful spread of stars across a black canvas, the comforting presence of something known. But what you would find instead is a sky slowly erasing itself. At first, things would appear mostly the same. The stars behind you would remain where they were, twinkling softly, sending out their last photons toward your disappearing path. The galaxies you passed through would linger in your instruments, some distorted by motion, others drifting out of view as the ship pressed onward. But as your speed continued to stretch toward the limit, that unreachable horizon of light itself, the universe around you would begin to change. Not in a sudden or dramatic way, but slowly, subtly, with a steady confidence of physics unravelling comfort. First, the stars ahead would start to cluster. They'd seem to gather toward the centre of your view, a consequence of your rapid motion compressing the field of vision. Space, once wide and sprawling, would seem to narrow. Galaxies once far apart would draw together in your line of sight, pulled into a cone of perspective shaped by speed and relativity. And the light, it would shift. The blue end of the spectrum, normally invisible to human eyes, would begin to dominate. The faster you move toward a light source, the more its wavelength is compressed, a phenomenon known as blue shift. Just as the pitch of a siren rises when it races toward you, so too does the colour of incoming light climb in frequency. What once appeared as gentle starlight would now shimmer in ultraviolet, X-rays, even gamma rays. The universe ahead would glow, but in wavelengths your body could not endure and your eyes could not see. At the same time, the cosmic microwave background, that ancient radiation left over from the birth of the cosmos, would cease to be a subtle hum and become something far more intense. To someone standing still, the CMB is a cool 2.7 Kelvin, a whisper from the earliest light. But for you, rushing toward it at nearly the speed of light, it becomes hotter, brighter, more aggressive. That background glow becomes a kind of wall of energy, pushed up the spectrum, no longer the calm murmur of a young universe, but something sharpened by your approach. Behind you, the opposite happens. Light stretches, red shifts. What you leave behind becomes dimmer, longer, cooler, until eventually it vanishes into darkness. The The stars recede, their colours fade, their shapes elongate like brushstrokes in a dream, and then nothing. There is a point where the ship, your ship, sees almost nothing but blackness behind it, and a distorted tunnel of intensity ahead. It's not that the universe has vanished, only that your motion has changed your relationship to it. What was once evenly lit becomes directional. What was once familiar becomes alien. The past grows cold and quiet. The future glows too hot to understand. You might begin to feel as though you're in a tunnel, not a physical one, but one shaped by perception and speed. The stars are no longer scattered across a dome but smeared across a needlepoint, clustered in a direction rather than a sky. There is still motion, still distance, but the richness of the universe's structure begins to collapse into vectors and gradients, into colours that no longer correspond to sight, into radiation that doesn't feel like light at all. And then comes the loneliness, because beyond the technical distortions, beyond the shifting wavelengths and melting star fields, there is something harder to name: the absence of presence. When you are cut off from home, when your signals can no longer reach Earth and no return is possible, the meaning of the journey changes. You're not exploring anymore. You're dissolving into time. No messages will arrive. No new stars will appear. Eventually, even the galaxies you once used for orientation fade into the cosmic expansion, their light unable to keep up with your motion. The sky grows thinner, the blackness grows deeper, and all that remains is the interior of the ship, the ticking of your onboard clock, the silence of the void, and the knowledge that you are witnessing the slow death of visibility. Not because the universe has ended, but because you've outrun its voice. Still, there is a strange beauty in this. To be alone in this way, not abandoned, not forgotten, but simply ahead, is to become a kind of time traveller, a sentinel. You're seeing a version of the cosmos no one else will see, a universe stripped of its decoration, showing you not its warmth, but its structure, the scaffolding of space-time, the raw geometry of the cosmos in motion. And if your journey continues, you will pass even those last shreds of light. You will drift into a region where nothing new arrives. No photons, no echoes. Just a darkness so complete that it becomes a mirror, reflecting not what is there, but what is no longer. It is not frightening. It is not cruel. It is only space. Pure and distant, unconcerned with observation, welcoming you not as a visitor, but as part of the landscape. You have left the universe of stars. You now sail in the sea of silence. And in that silence, the edge of perception is no longer a line. It is a stillness that surrounds you. Now imagine staying on this ship, not just for decades or centuries, but for as long as time itself allows. Let's suppose the vessel keeps moving forward, quiet and unwavering, toward nothing in particular. There is no target, no destination, only the slow ticking of onboard time and the universe rushing past in silence. From your frame of reference inside the ship, very little changes. Perhaps you read books, perhaps you sleep, perhaps you simply listen to the soft hum of systems, to the gentle rhythm of thought. But outside, something extraordinary is happening. The rest of the universe, the one you've left behind, continues to age. While your ship inches forward through an emptying cosmos, time outside is accelerating. Because of the immense speed of your journey, so close to the speed of light that the numbers themselves begin to blur, time dilation has become extreme. You may experience only a few centuries inside the ship, but outside, trillions upon trillions of years pass. Civilizations are born, reach their height, and vanish. Stars shine and die. Galaxies grow sparse. The grand fireworks of the cosmos begin to burn out. Eventually your ship emerges, not into a new frontier, but into a future epoch of the universe. a place so far ahead in time that even the term far future feels inadequate. We're not talking millions or billions of years anymore. We're talking about 10 to the 41st power years into the future, a number so vast it stretches comprehension. By then, the universe has entered what cosmologists call the degenerate era. There are no new stars forming. The luminous age of the cosmos is over. All the hydrogen that once gathered into suns has been consumed or scattered. What remains are the leftovers, the skeletal remains of creation. White dwarfs, faint and cooling. Neutron stars, collapsed remnants of once massive giants. Black holes, silent and undetectable unless disturbed. Space has grown cold. Galaxies have faded. The warm light that once made the universe feel rich and full has dimmed into embers, and even those embers are fading. As your ship glides onward, there is no longer a starfield to admire, no constellations to recognise. The sky is not empty exactly, but what's there lies mostly beyond detection. Particles decay, orbits slow. The great structures of the universe dissolve not in drama, but in entropy. That's the guiding principle now. Entropy. The slow and steady increase of disorder. In the earliest days, entropy meant stars igniting and galaxies clumping. But in this age, entropy means decay. It means loss. It means a soft collapse into silence. Eventually, even the black holes begin to vanish, not all at once, but gradually, by emitting faint radiation over unimaginable spans of time. Hawking radiation, as it's called, leaks from their edges. The largest black holes last longest, but even they, given enough time, evaporate into nothing. No bang, no explosion, just gone. And still, your ship flies on. What does it mean to arrive in such a universe? What does it feel like to emerge into a cosmic graveyard? A place where the party ended eons ago, where no one is left to tell the stories of how it once was. Perhaps the ship's instruments detect the final flickers of heat, a fading trail from a white dwarf collapsing into a black dwarf, or the last gravitational whisper from two cold, dead objects drifting apart. Perhaps there is nothing to measure at all, not because you lack the tools, but because the universe itself has become too quiet to speak. Even radiation, the most basic communication of energy, becomes scarce. The background temperature of space drops close to absolute zero. Motion slows. Change itself becomes rare. You are, in every sense, alone. But here's something to hold on to. This is not a tragic loneliness. It's not sad or cruel. It is simply the natural end of a long story. The universe was not promised to last forever in its youthful glow. It was always going to dim, always going to rest. You have just arrived early, or perhaps very late, depending on how you count. And this final stillness, it has a beauty of its own. Because if you listen, not with ears, but with imagination, you might still hear the echo of what once was. You might remember that every atom of your ship, every flicker of your onboard light, was forged in stars that are now long gone. You are in some quiet way a museum of the universe, carrying memory through motion. Perhaps your vessel drifts past the black remnant of a galaxy. Not a cluster of stars, but a gravitational structure, an outline of what once was. You cannot see it. But the instruments twitch ever so slightly, marking its presence. A ghost in the dark. Or perhaps your ship passes nothing at all. Just pure vacuum. A place where even photons have ceased their travels. Where distance and direction no longer mean what they once did. And yet, you are still moving. Even here, in this far future, motion remains. Not because of engines or destination, but because of inertia. The first law of motion, still honoured long after the fireworks have faded. Your journey continues, not toward a place, but into meaning itself. You are the last witness, and the universe, though dark, still wraps around you. Not coldly, but like a quiet room after a long evening. emptied of noise but filled with memory. By now you've travelled so far, not only through space but through time itself, that the question seems almost ceremonial. Could we ever return? Could this long, lonesome journey find its way back to the warmth of home, to the bright age of stars, to the shared breath of an inhabited Earth? It's tempting to imagine a way. After all, the ship is intact. The engines, at least in theory, could reverse there, burn. The instruments still work. The course could be plotted, a path calculated. The mathematics could be fed into a perfect machine, and the vector home could, in principle, be drawn. And yet, no matter how carefully we imagine it, the answer is no. Not because of failure, not because of damage, but because of something far quieter, a fact of the universe that cannot be reversed by will or wonder. The very fabric of space has changed. In our familiar world, when we walk away from something, we can walk back. When a boat drifts out into the ocean, it can, with enough strength or luck, return to shore. But the universe does not offer that same symmetry. Because unlike a sea or a room, space isn't static. It stretches. It changes while you move through it. It expands beneath you, carrying everything farther apart. Not because you move, but because space itself is moving. You might turn your ship around. You might reverse course, point your nose back toward the dim light of the galaxy you once called home. You might fire the engines and slow your drift, begin a long journey home. But even then, space continues to stretch. Every second of progress is swallowed by the relentless widening of the cosmos, like walking down an escalator that grows longer beneath your feet. Every step you take is undone by the motion of the structure itself. This is the result of what physicists call metric expansion. The idea that space doesn't expand into anything, but rather grows in and of itself. There is no outside of the universe into which it spreads. The expansion happens everywhere, and it happens continuously. At local scales, between planets, within galaxies, gravity holds space tightly. Expansion is imperceptible. But at cosmological scales, especially in the vast voids between galactic clusters, the expansion becomes dominant. So dominant, in fact, that beyond a certain distance, space begins to expand faster than light. And once you've crossed that threshold, that horizon of causal disconnection, no effort, no propulsion, no reversal can bring you back. Not because you can't move fast enough, but because there's no longer a path to follow. The road home is being erased behind you, stretched thin until it snaps. It's not the distance that traps you. It's the change in the rules themselves. You might imagine a tether, something that could pull you back. Gravity, perhaps, from your home galaxy. But the truth is, gravity weakens with distance, and across billions of light years it loses its grip. There is no gravitational leash strong enough to counteract the accelerating pull of expansion. The farther you go, the more that tether fades, not gradually, but irreversibly. Wormholes might come to mind, those hypothetical tunnels through space-time. In science fiction, they often offer a loophole, a shortcut, a miraculous return. But in reality, if they exist at all, they require exotic matter, immense precision, and conditions we have yet to observe or create. Even then, their stability under relativistic conditions is uncertain at best. They are beautiful ideas, but not bridges you can count on. And so, slowly, the truth settles, not with bitterness, but with clarity. This is a one-way journey, not because you failed, but because the universe does not rewind. Its nature, stretching, growing, untangling from its own early density, ensures that certain places once left can never be revisited. Not because they're far, but because they've slipped into a region of space-time where the lines no longer connect. And that, in a strange way, is what makes this journey meaningful. To go forward, knowing you cannot return, is a kind of cosmic trust. You have handed yourself over to the nature of reality, not to conquer it, but to understand it. You're not a hero, Not a conqueror, you're a witness, a small traveller on a quiet ship floating on currents that cannot be reversed, in a sea that does not close behind you, but simply forgets where you've been. Yet even as the possibility of return disappears, something else remains. Memory. The memory of the sky as it once was, the shape of your home galaxy, etched in starlight and soft gravity, the warmth of the cosmic past now receding but never erased. It travels with you, not in the ship's data logs, but in your very atoms, in the materials forged in ancient suns, in the physics that shaped your vessel, in the language you still think in. You're not gone from the universe, you have simply moved into its future, and in that future, though it may be dark, there is still motion, there is still form, there is still wonder. So no, we cannot come back, but we can go forward, and sometimes that is enough. You've been travelling through the cosmos for what feels like a quiet eternity, floating far beyond any hope of return. You've passed through boundaries of reachability, perception, and even time. But now a new question rises, not about where you're going, but about what you're moving through. What exactly is the shape of space? It's easy to picture the universe as a kind of vast empty room, an endless black box with scattered galaxies as its stars. But that's just an image, and images, while comforting, can often be misleading. Space isn't a static stage. It bends, it curves, it expands, and its geometry, the very rules that govern how it's stitched together, shapes everything we see, even the paths we think are straight. So, what shapes are possible? Mathematically, the universe can take on three broad geometries: flat, open, and closed. These are not metaphors, but deep physical realities, each one changing how light travels, how gravity behaves, and how the universe evolves over time. In a flat universe, parallel lines stay parallel forever. Light moves in straight lines, triangles behave just like they do on a piece of paper, and the angles of those triangles always add up to 180 degrees. It's the simplest to imagine. An infinite sheet that goes on and on, neither curving nor folding. It feels intuitive, and for a long time, many scientists assumed this was the default. But then there's the closed universe. Here, space curves inward, like the surface of a sphere. If you draw a triangle on a sphere, say, with its corners at the North Pole and the equator, you'll find the angles add up to more than 180 degrees. Lines that begin parallel eventually meet, travel far enough in one direction, and you could return to where you started, not because you turned, but because space looped beneath you. And finally, there's the open universe, a saddle-shaped geometry. In this model, space curves outward, like the seat of an old wooden horse. Triangles drawn here will have angles that sum to less than 180 degrees. Light diverges, lines stretch apart, and the universe expands forever in all directions, but without ever folding back in on itself. How do we know which shape we live in? That's where a curious dreamer from history comes in. Carl Friedrich Gauss, a mathematician so thoughtful that he once tried to measure the universe's shape by surveying the angles of a triangle made from three distant mountain peaks. If the triangle's angles deviated from 180 degrees, even by the tiniest amount, it might mean space was curved. The idea was clever, poetic even. But in practice, Earth was too small and the measurements too imprecise to say anything about the cosmos at large. Gauss, though, planted a seed, and that seed eventually grew into one of the most delicate tools in modern cosmology, the study of the cosmic microwave background. You remember the CMB, that ancient light, stretched and cooled, still glowing faintly from all directions. It doesn't just tell us how old the universe is, it tells us how space is shaped. The tiny variations in the temperature of that background, the little hot and cold spots scattered across the sky, carry within them the fingerprint of space's geometry. If the universe is flat, the spots appear a certain size. If it's curved inward, they look slightly larger. If curved outward, they shrink. By carefully measuring those patterns, scientists can infer the shape of the canvas on which the universe has painted its first light. And what do the measurements say? To the best of our current understanding, the universe appears to be flat. Not precisely, not perfectly, but so close that any curvature must be incredibly slight, too subtle to detect with today's instruments. That doesn't mean space is definitely infinite, but it does mean, on the largest scales we can measure, it doesn't curve in any obvious way. The reason for this flatness likely lies in the early history of the universe, in a moment known as cosmic inflation. Right after the Big Bang, the universe expanded at an astonishing rate, stretching tiny quantum fluctuations into cosmic structures and smoothing out any curvature that may have existed. Like inflating a balloon so rapidly that any wrinkles disappear, inflation flattened the cosmos, not to perfection, but to a degree so precise that even billions of years later, we still see its echo. And yet, flat doesn't mean boring. Even in a flat universe, fascinating things happen. Galaxies form, stars ignite, black holes bend space into wells. Locally, space can curve. Gravity still warps it like marbles on a trampoline. But on the grandest scale, across hundreds of billions of light years, space seems to lie calmly, without obvious bends, a quiet plane on which the drama of time unfolds. But here's where things remain delightfully open. We don't know for certain. Our instruments are good, but not perfect. The observable universe, our cosmic bubble, may be too small a sample to reveal the true shape. Just as a sailor on a calm sea may believe the earth is flat, we too might be fooled by the scale of our vision. So the question lingers, could the universe bend, ever so slightly, over distances we'll never see? Perhaps. And even if it doesn't, even if space truly is infinite and flat, the sheer enormity of that idea is enough to make any thought feel small. The shape of space isn't just a curiosity. It is the architecture of existence, the blueprint beneath galaxies, the silent frame through which light has travelled for billions of years. And whether it curves, loops, or stretches forever, you are part of it, not on the edge, not at the centre, but gently floating within its folds. Let's imagine for a moment that you're a creature living on a flat sheet of paper. You can move forward and backward, left and right, but up and down mean nothing to you. Your world is two-dimensional, like a quiet tabletop stretching forever in all directions. Circles are circles, squares are squares, and the idea of a sphere is as foreign to you as silence is to a song. Now, suppose a hand, a three-dimensional hand, passes through your paper world. What would you see? Not fingers, not a palm. You'd see a strange sequence of events. First a point, then a widening shape, perhaps like a ring, then a narrowing again, and finally nothing at all. A ghost of something larger, misunderstood, not because it's invisible, but because it lives outside your ability to perceive. And now, what if we are like that? What if we, the three-dimensional thinkers, are moving through a higher dimensional space we cannot see? The idea isn't science fiction, it's an honest question in physics, and while we don't yet have proof that such higher dimensions exist, the mathematics doesn't forbid them. In fact, some of our best theories suggest they're not only possible, they may be necessary. When scientists explore the deepest workings of reality, the tiniest particles and the most fundamental forces, they find that our familiar three dimensions of space may not be the whole story. The elegant frameworks of string theory, for example, don't work in 3 or even 4 dimensions. They require 10 or sometimes 11, depending on the version. Not because someone dreamed up extra space for fun, but because the equations, quiet, careful equations, simply stop working without them. But if those dimensions exist, where are they? Why don't we see them when we walk around the world or look at the sky? The answer may lie in how dimensions behave. Some could be compactified, curled up so tightly that they're imperceptible at human scales, like a garden hose seen from far away. From a distance, the hose looks like a line. But if you're an ant, walking along its surface, you know there's more. A loop, a wraparound path invisible from afar. Our universe, too, could be wrapped around itself in ways we can't directly experience. Or perhaps the higher dimension isn't small, but we are stuck inside a lower dimensional surface. A brain, as theorists call it, short for membrane. In this view, all the matter and forces we know, light, atoms, gravity, are confined to this three-dimensional brain, floating in a higher dimensional space like a soap bubble in the air. And the edge of the universe? It might not be out there, in distance, in light years, in unreachable coordinates. It might be all around us, folded gently into a fourth spatial direction, one we cannot turn our heads to see. Just as the two-dimensional creature could not look up, we may be unable to look through the very curvature that contains us. This isn't an idea designed to frighten. It's not about being trapped. It's about humility. A soft understanding that our perception is shaped by the world we evolved in. A world of apples and stones and stars. We see three dimensions because that's what we need to survive in. But physics may know more. Even Einstein's own theories hint at it. General relativity shows us that space can bend and twist in the presence of mass. Black holes curve space-time so severely that time slows down and distances behave strangely. If space can curve within itself, why not around something larger? And here's where metaphor helps. Imagine again our paper-flat creatures. They draw circles, they walk straight lines. But suppose their flat world is really wrapped around a balloon. Not tight like a knot, but stretched gently across a curve. From their perspective, the universe is flat. Walk far enough in one direction, and they return to where they started, never realizing that they've gone in a great loop. To them, the edge does not exist. But from our perspective, we can see it clearly. We see the curve they cannot. Now flip the analogy. We are those creatures. We live in three dimensions, but the curve, if it exists, is not into a fourth that we can reach or see. It may surround us, invisibly, embedded in a higher spatial fabric that contains our entire reality, like a page in a book whose cover we cannot read. And so, when we ask, where is the edge of the universe? The answer might not be a direction. It might be a dimension. The edge may not lie at 46 billion light years. It may be right here, enfolded invisibly beside us, too close to touch, too strange to map. Even if string theory and M theory fade with time, replaced by new ideas, the wonder they inspire remains. They invite us to think bigger, not about larger distances, but about deeper structures, about truths that don't contradict what we see, but gently explain why we can't see more. You're not small because you cannot perceive the higher dimension. You're simply shaped by three, and that too is beautiful. Let's say you board that silent ship once more. You set the controls, choose a direction, any direction, and begin to move. Slowly at first, then faster. Decades pass. You leave galaxies behind like breadcrumbs. Centuries drift by in the quiet hum of engines and memory. You pass through the boundaries of what was visible, what was reachable, what was thought possible, and still you keep going. Now pause for a moment and ask a gentle question. What if this path doesn't lead outward forever, but inward again? Not in the sense of turning around, not in the way a traveller returns from a journey by retracing steps, but what if, just by going straight, you find yourself arriving back where you began? Not because you made a mistake, but because the universe is curved. Not visibly, not sharply, but topologically. This is the quiet suggestion hidden inside the idea of a finite but unbounded universe. It sounds like a contradiction. How can something be finite, have a defined size, and yet have no edge. But of course, we've seen this before. The surface of Earth is exactly that. You can walk in any direction for as long as you wish, and you'll never fall off. No cliff marks the end of the planet, and yet Earth is not infinite. Its surface is curved into a sphere. Its finiteness is wrapped in a loop. Now, take that idea and lift it into 3 dimensions. What if space itself loops back on itself? Imagine the universe shaped not like a flat sheet or a boundless box, but like a 3 torus, the 3-dimensional equivalent of a donut. In such a universe, heading in a straight line in any direction might eventually lead you right back to your starting point, even though you never once turned. The edge never appears because it doesn't exist. The universe wraps, gently and seamlessly. In this model, the edge of the universe isn't a place. It's a misunderstanding of shape. And you might ask, if that's true, shouldn't we notice? Wouldn't we see the same galaxies multiple times? Wouldn't light from a distant object travel around the universe and reach us from more than one direction? The answer, beautifully, is maybe. Cosmologists have looked for patterns, repeated imprints in the cosmic microwave background, familiar arrangements of galaxies, mirrored structures in the large-scale scaffolding of the cosmos. If the universe does loop in this way, light from the same object might reach us along different paths, creating copies. Not new things, but the same thing seen twice or more. So far, no clear duplication has been found. But absence of evidence is not evidence of absence. The universe may be too large for light to have completed a full circuit since the Big Bang. Or the topology might be more complicated than a simple loop, twisting in ways that delay the repetition or scramble the signals. We might live in a shape that bends and folds in ways our measurements cannot yet resolve. Still, the idea lingers. A universe that wraps isn't strange, it's elegant. It doesn't require a boundary or an outside. It doesn't need a final edge or a place where things stop. It only requires that space curves, not sharply, not locally, but globally, over distances so vast we cannot hope to walk them, even with light as our guide. And what would it feel like aboard your ship to begin recognizing the signs? Perhaps after a long enough time you'd spot a galaxy that looked familiar, not just similar, but exactly the same. A unique pattern in its spiral arms, a certain arrangement of its satellite companions, a glow that matched data you recorded long ago. Could it be coincidence? Perhaps. Or perhaps you've arrived, not at the destination, but at the origin, without turning, without slowing, just by continuing. And if you looked back, the path would be invisible. Light moves too slowly, the circuit too vast. No trail marks the journey, no breadcrumb glows in your wake. Only the recognition, the gentle astonishment. You never found the edge, you simply returned. Some might find this unsettling, the idea that even at cosmic scales you can never truly escape. That space folds in on itself, and the furthest distance is a return to the beginning. But perhaps to a quiet mind this is comforting. A universe with no edge, no final wall, only paths that circle, like thoughts returning after long detours, like music that repeats a motif, like dreams that begin again in slightly different ways. We often ask, what lies beyond? But sometimes the answer is nothing. Not because nothing exists, but because everything is already contained, not in a box, not in a shell, but in a loop. And you, the traveller, the thinker, the sleeper adrift in space, are moving through that loop, not lost, but part of its rhythm. Wherever you go, you're already somewhere, and wherever you begin, you're never far from return. You've followed loops and curves, traced the possibilities of returning where you started, and now the path opens once more. No more edges, no more turns, just the simplest and perhaps strangest possibility of all. What if the universe doesn't wrap around? What if it doesn't fold or close or end in any direction? What if space is, quite simply, infinite? It's a word we use lightly in everyday life. Infinite patience, infinite scrolling, infinitely small. But in cosmology, infinity is not a poetic exaggeration. It's a genuine proposition. A universe with no bounds, no loops, no limits. A place where space stretches outward forever in every direction, never repeating, never folding in, never running out of room. And if that's the case, then something quietly extraordinary follows. In an infinite universe, made from a finite set of building blocks, a finite number of atoms, particles, laws, then statistically, every possible arrangement must not only occur, but occur an infinite number of times. Think of it like this. There are only so many ways to arrange the letters of the alphabet into words, only so many ways to place atoms into molecules, only so many configurations for a brain, a hand, a memory. Given infinite chances, those arrangements must repeat, not just once, but endlessly. Across the unfathomable sea of space, the same stars must reassemble. The same minds, the same thoughts. Somewhere, impossibly far away, there may be another version of you, not similar, but identical. Reading these words, thinking these thoughts, aboard a ship not unlike the one we imagined, and not just one version, but infinite variations, one where you paused halfway through, one where you smiled, one where you read it aloud, one where the stars outside are blue instead of red. And beyond that, an even stranger frontier, lie the almost yous. Those whose lives differ by a single word, a single breath, a single photon that struck their eye at a slightly different angle. If the universe is infinite, then every possible configuration of matter that is physically allowed must happen somewhere, somewhen. That means somewhere there's a planet like Earth, down to the finest grain of sand, and somewhere else there's an Earth where dinosaurs never went extinct, and civilizations speak in clicks and colours, and farther still, an Earth where gravity is just slightly weaker, and mountains rise so high they touch the edge of atmosphere like frozen smoke. It's not parallel universes in the multiverse sense. No branching timelines or alternate quantum outcomes. It's simpler than that. It's just a matter of combinatorics in endless space. The implications are staggering, dizzying even. For some they are comforting. You're not alone, they say. You're part of a cosmic chorus, each voice echoed and varied across infinity. For others, it feels like a horror, a flattening of meaning. If everything happens somewhere, then what matters? If every sorrow and every joy is copied endlessly, do they lose their weight? But perhaps meaning doesn't come from uniqueness. Perhaps it comes from presence. From being here, in this one configuration, at this one moment. You are not less real because a version of you exists 1 trillion light years away. You're not diluted by the existence of echoes. You are simply part of the richness of it all, a single thread in a tapestry that goes on forever. And even if we could never reach those places, and we never could, the idea of them shapes how we think about space. Not as a map to be completed, not as a puzzle to be solved, but as a meditation, a vast and quiet question with no need for an answer. In this kind of universe, exploration changes. It's no longer about finding what's out there. It's about understanding what's here, and recognizing that what's here may also be there, again and again, in forms both familiar and strange. And what of the edge? In an infinite universe there is none, not even conceptually. There is no point where you can stand and say, here the universe ends. For any point you choose, there is always farther still, always more galaxies, more voids, more silence, always another version of a thought, a hand, a laugh. In such a place you don't reach the end, you only continue. And the only true boundary becomes the one we carry within, the limits of perception, of memory, of imagination. Because even if the cosmos contains everything, we do not. We are small beings with small windows drifting through a space too large to ever know in full. But that perhaps is what makes it beautiful. Not because we can see it all, but because we can see any of it at all. To exist in such a place, to be conscious, curious, listening, is already a miracle, whether there are copies or not, whether infinity folds or loops or drifts endlessly on. Tonight you are here, and this version of you, this one, is enough. The night sky feels still, a soft canopy overhead, dotted with stars that appear fixed in their places, as if the universe were a great stage holding its breath. But this stillness is an illusion. Everything is moving, not gently, not slowly, but at incredible speeds, racing outward into deeper and deeper space, and not just moving, accelerating. This discovery, quiet and unassuming at first, rewrote our understanding of the cosmos. In 1998, 2 independent teams of astronomers set out to study the fate of the universe by observing distant Type Ia supernovae, bright, consistent explosions in galaxies so far away their light had been travelling toward us for billions of years. The goal was simple: measure how fast the universe had been slowing down over time due to gravity. But what they found was something else entirely. The universe wasn't slowing, it was speeding up. This meant that galaxies weren't just moving away from each other, they were doing so faster and faster as time went on. Some distant galaxies were receding from us so quickly that no signal sent now would ever reach them, and, worse, many galaxies we can currently see are already on their way out of view. Their light arriving at our telescopes now left them billions of years ago, but the space between us has stretched so much that those galaxies are no longer in touch with us in any causal sense. They are becoming permanently unreachable. What could cause this? The answer, as far as we can tell, is something called dark energy, a name given not because it's sinister or malevolent, but because we simply don't know what it is. It's not a kind of matter. It doesn't clump or form structures. It doesn't emit light. It doesn't seem to interact with anything in a familiar way. It's not like gravity, which pulls, or electromagnetism, which pushes and pulls. It's something else entirely. The simplest explanation is that dark energy is a property of space itself, that even in the vacuum, the emptiest nothing you can imagine, there remains a kind of latent energy. And as space expands, more space means more energy, and more energy means more expansion. A quiet feedback loop, invisible to the senses, pushing galaxies apart faster and faster with each passing moment. This expansion isn't like objects flying outward through an explosion. It's not that galaxies are moving through space, it's that space is stretching between them. Like dots on the surface of a balloon being inflated, galaxies are carried apart by the growth of the medium they sit in. And just like the balloon analogy, there's no central point. Every galaxy sees every other galaxy moving away, no matter where you are. Now, this expansion has always been happening ever since the Big Bang, but for most of the universe's life, gravity had been slowing it down. Matter, galaxies, stars, clouds of gas, pulled on everything else, resisting the spread. For billions of years, expansion and gravity played a kind of tug-of-war, one slowing the other, both shaping the cosmos. But eventually dark energy took over. It wasn't a dramatic moment. There was no flash, no shift in colour or tone. Just a gentle transition, quiet and inevitable, where expansion gained the upper hand. And now the balance is gone. Gravity still shapes the local universe, holds galaxies together, binds solar systems, but on the grandest scales, it has lost the war. The universe is no longer coasting. It is accelerating into isolation. What does that mean for us? In the short term, the next few billion years, not much. Our galaxy, the Milky Way, is gravitationally bound to its neighbours, including Andromeda, and they will eventually merge in a slow celestial dance. local structures will remain intact. Stars will still be born, live and die. The solar system will still orbit its calm star. But beyond our cosmic neighbourhood, the lights are dimming. Galaxies farther away will disappear from view, not because they've gone dark, but because the light they emit will be stretched, red-shifted. Beyond the reach of detection, they will slide across the cosmic horizon, a moving boundary beyond which no new information can reach us. The universe, once full of distant companions, will become quieter, emptier, more alone. And eventually, far in the future, a time will come when observers, if any still exist, will see only their local cluster. Nothing more. No evidence of the Big Bang. No whisper of other galaxies. No hint that the universe was ever larger than what their eyes can see. Cosmology as we know it will become impossible. Not because the truth has changed, but because the evidence has slipped away. This, then, is the legacy of dark energy. Not a bang, not a collapse, but a slow retreat into silence. A stretching of space that pulls everything apart until all connections are lost. Not emotionally, but causally, mathematically, irreversibly. And yet, as strange as this fate may sound, it is not a punishment. It is not a flaw in the design. It is simply the shape of reality, gently revealed over time. The universe was never promised to remain familiar. It was never built for our comfort. But it is beautiful in its honesty, in how it continues quietly without apology. So tonight, as you drift in thought across the stars, know this: the universe is running away. But for now you are still watching, and that is a kind of grace. Imagine standing in a house where every candle has gone out. No footsteps, no clocks ticking, no voices murmuring in the rooms beyond. Just stillness. Not the kind that comes before something happens, but the kind that means nothing more will. This is not a place of fear. It's simply a place where everything is finished. That's what the far future of the universe looks like. Not in one moment, not with a great crash or cataclysm, but in an unfolding that takes place so slowly that it becomes indistinguishable from silence. A fate that physicists call, without poetry but with precision, the heat death of the universe. Or sometimes, more gently, the big freeze. To understand it, we have to return to one of the oldest ideas in all of physics: entropy. Entropy is, at its heart, a measure of disorder, or more precisely, the number of ways a system can be arranged without changing its overall appearance. A hot cup of coffee cools not because heat vanishes, but because it spreads into the air. The molecules of warmth drift outward, their order dissolving into randomness. Eventually the room and the coffee reach the same temperature. No more flow, no more difference to exploit. And that's the rule. Entropy always increases. Left to themselves, systems become more uniform, less structured. The universe, vast and complex as it is, obeys the same law. In the beginning, there was low entropy. The early universe was smooth and hot, filled with dense, radiant energy. But over time, stars formed, galaxies spun, and structures took shape. Not because entropy decreased, but because it had room to grow. Stars are like little engines of entropy. They take ordered hydrogen and fuse it into heavier elements, releasing light, spreading heat, increasing the disorder of the universe, and eventually they run out. One by one, the stars go dark. The big ones explode. The small ones cool into white dwarfs, then black dwarfs, no longer burning, just slowly radiating away their remaining heat. Planets become frozen husks. Moons drift in silence. The spaces between galaxies grow wider. Black holes dominate, quiet, heavy, invisible and less disturbed. But even they are not eternal. Through a slow process called Hawking radiation, black holes leak energy. Tiny, imperceptible amounts, spread over inconceivable timescales. The larger the black hole, the longer it takes, but eventually even the giants evaporate into particles and vanish, leaving behind only the faintest whispers of their presence. And then what's left? A universe with no stars, no galaxies, no light, just scattered particles, electrons, neutrinos, perhaps remnants of protons if they haven't decayed. A space so vast and so empty that collisions become rare, and change becomes rare, and time itself begins to lose its meaning. Because time, at least as we experience it, is marked by change. Clocks tick because gears move, days pass because planets spin, stories unfold because events happen. But in this future, nothing happens. Not because it's frozen, but because all differences have smoothed away. There is no more usable energy, no more gradients to drive motion. The temperature of the universe approaches a constant, uniform chill, a whisper above absolute zero. This isn't a sudden end. It's not an apocalypse, it's a drift, a slow dissolving of structure into equilibrium. The cosmos doesn't die, it rests, and it rests forever. There's something haunting about this, not terrifying but melancholic. The idea that all complexity, all structure, all life, all thought will eventually give way to calm. That stars, for all their heat and fury, are temporary. That black holes, for all their mystery, are transients. That even light itself, born in bursts of brightness, will one day redshift into nothing. Stretched so thin by expansion that its wavelength becomes effectively infinite. But in this there is also a kind of comfort. Because this ending is not cruel. It is not chaotic. It does not take with force. It simply allows things to conclude. The universe gives everything the time it needs. Billions of years for stars to shine, trillions more for galaxies to dance, eons upon eons for particles to whisper their last energies into the void. And we, living now in a moment of brightness, in a universe still warm, still full of light, are part of that story. Not because we witness its end, but because we exist before it. We are here, in the rare moment when the universe sings, when entropy still has room to grow, when change still dances across the sky. The eventual heat death doesn't diminish that. It gives it context. When you light a candle, you know it will go out. That doesn't make its glow less beautiful. In fact, it makes it more so. And so, as you float in thought through this future, this cold, quiet, beautifully still cosmos, know that the silence is not empty. It is full of memory. Every particle, every faint pulse of radiation carries the history of what once was. Stars that burned, lives that laughed, eyes that looked up and wondered what came next. And now you know, not the end, but the soft continuation. The music faded, the room darkened, the warmth gone, but not forgotten. Imagine looking up at the night sky and seeing only darkness. No galaxies, no scattered light from distant stars, no soft glow from neighbouring clusters, just a velvet void stretching in every direction, still, deep, and mostly silent. It wouldn't happen all at once. The stars in our own Milky Way would still shine for billions of years. The nearby galaxies in our local group would remain bound by gravity, slowly merging into one massive structure over time. But beyond that, beyond the few dozen galaxies close enough to cling together, the rest of the universe would begin to vanish. Not because it's ending, but because it's slipping away. This vanishing act isn't a trick of the eye or a flaw in the telescope. It's a quiet consequence of the same force we explored earlier, dark energy. Because of it, the universe's expansion isn't just continuing, it's accelerating. The space between distant galaxies grows not linearly, but exponentially, pushing them away from us faster and faster with every passing moment. There is a boundary to this, not a wall, not a shell, but a horizon. A cosmic event horizon. Just like a black hole's edge marks the place beyond which nothing can return, The universe has a boundary beyond which light itself can no longer reach us, no matter how long we wait. This distance isn't fixed. It changes as the universe expands. But roughly speaking, the edge of what we'll ever be able to see, the cosmic light horizon, is about 61 billion light years away. Galaxies beyond that are already lost. Their light is travelling toward us, but space is expanding faster than the light can make progress. It's like trying to walk up a down escalator that's accelerating beneath your feet. No matter how fast you move, you're carried farther away. But even galaxies within the horizon are fading. Every second, photons from distant stars stretch, their wavelengths pulled longer by the expanding space they traverse. This is called cosmological redshift. The further the light travels, the more it shifts toward the red end of the spectrum. Eventually, even visible light becomes invisible, stretched into radio waves, microwaves, then nothing detectable. So, over the next trillions of years, galaxies will vanish. Slowly, elegantly, not by ceasing to exist, but by slipping below our threshold of detection. First the most distant, then those just slightly farther than we are from the edge, then closer and closer still. One by one, the galaxies we now see with modern telescopes, billions of them scattered like jewels across deep field images, will cross that horizon, until one day none remain. The universe will still be vast, still expanding, still full of galaxies, stars, motion and memory, but we will no longer see them, not because we're blind, but because the universe has changed the rules, and eventually even our own galaxy will begin to empty. The stars of the Milky Way will age and die. Some will become white dwarfs, others neutron stars, some will collapse into black holes. Star formation will slow, then cease, as the raw material, the hydrogen and helium, are consumed or lost. The galaxy will dim, and even within our own galactic home, the sky will change. Bright stars will wink out one by one, until only the dimmest embers remain. The night will grow less crowded. The constellations will deform, not because we've moved, but because their members have vanished. There will come a time when only a handful of stars remain visible from any point in the galaxy. And then, after many more billions of years, none. Eventually, all that will be left in the sky is the cosmic microwave background, the afterglow of the Big Bang. But even that will fade. As the universe expands, its temperature continues to drop. From 2.7 Kelvin today, it will fall further and further until the radiation is no longer detectable, its wavelength stretched into silence. There is a poetry to this, because what disappears isn't destroyed, it simply becomes inaccessible. The galaxies are still there, rushing outward, evolving, carrying their own stories. But from our perspective, they are gone. The light is lost to time and distance. We remain, watching the retreat, our view shrinking with each epoch. And here's the quiet truth. If intelligent life emerges in the deep future, perhaps on a distant moon, perhaps orbiting a fading red dwarf, they may never know what we knew. Their telescopes will reveal only their local stars, no distant galaxies, no evidence of expansion, no echo of the Big Bang. To them, the universe will appear static, eternal, and strangely small. Cosmology, the science of everything, will no longer be possible, not because they're not smart enough, but because the evidence is gone. We, living now, are in a privileged time, a brief window in cosmic history when the universe is still legible, when the sky is full of information, when galaxies whisper their distance through redshift, and the microwave background hums its ancient tune. We can see, we can know, and so, as the future draws its veil across the sky, we hold on to that knowledge, not as a possession, but as a gift. We were here when the sky was full. We were here when the universe told its story, and though the stars may disappear, we remember, and we listen for what fades, Picture a spacecraft built for the boldest mission in history. Not a journey to Mars or to a nearby star, but to the very edge of the observable universe. A mission not just of curiosity but of preservation. To reach the farthest galaxies before they slip beyond reach. To chase the last flickers of light before the darkness becomes permanent. It sounds noble, daring. And yet, no matter how advanced your technology, no matter how clever your propulsion, there is a truth that waits at the centre of it all. You cannot catch the edge, because the edge is not a destination. It's a horizon, one that recedes as you approach, always staying just out of reach, like a line drawn in water. No matter how fast you go, the universe will carry everything farther away even faster. And that's not poetic pessimism. That's physics. Let's start simply. Suppose you could build a ship capable of travelling at the speed of light. An impossibility according to Einstein's theory of relativity, but useful for thought. Even then, even moving at this ultimate limit, you would never reach certain galaxies. Because beyond a certain distance, space itself is expanding faster than any signal, any motion, any cause can propagate. This is not because those galaxies are moving through space at superluminal speed, but because the fabric of space between you and them is stretching, and there's no rule in physics that limits how far space itself can expand. General relativity allows it, and in fact, it requires it under the influence of dark energy. The farther you go, the more expansion works against you. It's like running on a treadmill that accelerates the faster you sprint. There is a cosmic speed limit, not for space, but for objects within space. And the more you try to approach the edge, the more it recedes. Galaxies are not escaping you. They are simply being carried by the current of space, and the current is flowing faster than any swimmer can manage. Now suppose you think bigger, not just fast, but clever. What about theoretical technologies? Things like warp drives or wormholes. The Alcubierre drive, for example, a hypothetical engine that can track space in front of a ship and expands it behind, allowing for faster-than-light travel without breaking local relativity. At first glance, it seems perfect. You're not moving through space, you're pulling space toward you. So why not reach the edge this way? But even here, reality pushes back. Warp drives, if they are possible at all, require exotic matter, negative energy densities that we have never observed and don't know how to produce. Worse, they are still bound by causal structure. You can't send information faster than light outside your local bubble. You might move the bubble, but you cannot control what lies beyond it. And expansion itself, cosmological, accelerating, horizon-defining expansion, is not something you can outrun. It happens everywhere, to everything, all at once. You are not in a river you can swim through. You're in a river that stretches with you in every direction. Even a wormhole, if you could stabilize one and place its ends strategically, wouldn't solve the problem. Because to place the ends, you'd need to have already reached the distant location. You can't drop an anchor in a sea you've never visited. And by the time you arrive, if you ever could, that point may have drifted beyond all hope of return. So what then do we make of this? If we cannot reach the edge, not now, not ever, does the idea lose its meaning? Number. It changes its meaning. Because the edge is not an invitation. It is a boundary of perception, a reminder that the universe does not exist for us to fully know, that some places, some galaxies, some ancient photons, some cosmic stories, will always be beyond. And that's not a failure, it's a frame, a way to understand where we are. You see, the beauty of a horizon is not that it can be touched, it's that it shapes the way we look at everything else. The sun setting behind the hills, the sea touching the sky, the galaxies vanishing beyond time. These are not tragedies, they are edges of vision, helping us focus on what we can see, while honouring what we cannot. There's a kind of peace in this, in knowing that we're not meant to reach everything, that some things exist not to be grasped, but simply to remind us of scale. And as our instruments grow more precise, as our math grows more exact, we find, not disappointment, but depth. We don't chase the edge because we expect to catch it. We chase it because the pursuit reveals the nature of the universe and our own place within it. And so, when you look up and imagine that mission, that ship flying outward into the thinning stars, chasing the last galaxy before it slips away, know that the journey is real, even if the goal is not. We're always moving toward understanding, always nearing the unreachable, and that is what it means to explore, not to conquer space, but to stand at the shoreline of knowing and listen. Beyond the light, beyond the galaxies, beyond the edges of everything we can see or measure, what remains? It's not an easy question. It isn't even one that science, as we currently know it, can truly answer. And yet it lingers, like a quiet thought you can't quite finish, like a dream you almost remember. We've spent this journey exploring the structure of the universe, the stretching of space, the limits of reach, the soft fade of stars. But now, with everything receding, with time itself unravelling in silence, one final mystery remains. What lies beyond? Not beyond the edge in a directional sense. There is no wall, no curtain you can walk through. The observable universe is bounded not by a shell, but by time and light, by the simple fact that we can only see what has had enough time to reach us. But what about outside that bubble? What about the parts of the universe we'll never see, even in principle? There are several possibilities. Some are physical, mathematical, and plausible. Others drift closer to philosophy. And some, perhaps the most honest, live between the lines, in a space where not knowing is its own kind of wisdom. One idea is simple and vast. The universe continues. The region beyond our horizon is not different. It's just more of the same. More galaxies, more stars, more space. Because light from those areas hasn't reached us yet, we remain in the dark, but the universe itself may go on endlessly. A fabric without seams. In this view, the edge is no different from any other part of the universe. It's not a place, just a limitation of vision, like a distant hill hidden by fog. But then come the deeper ideas, the ones that tremble slightly at the edges of our understanding. Some theories suggest that beyond what we can see, the laws of physics themselves might change. That what we call constants, the strength of gravity, the speed of light, the mass of particles, might be different in other regions of space. In this view, our universe is just one bubble in a larger multiverse, a cosmic foam where each bubble has its own rules, its own shape, its own history. We call these pocket universes or baby universes born from quantum fluctuations or spawned in the aftermath of inflation. Some may be tiny, others infinite. Most would be forever unreachable, causally disconnected not by distance, but by fundamental incompatibility. No signal could bridge them, no spaceship could visit. Still deeper lies the idea of the false vacuum, the notion that our universe isn't in its most stable state, but in a temporary valley in a cosmic energy landscape. If that's true, then somewhere, perhaps unimaginably far away, a more stable configuration may already exist and could, in theory, spread outward at the speed of light, transforming everything in its path, not with malice, not with sound, but with finality. The laws of physics would shift, particles would change, chemistry would unravel, existence, as we know it, would simply end. There would be no warning, no resistance, just the quiet arrival of a new reality, like a page turning in a book that no longer includes you. And yet, we do not fear this, because if it happens, we will not know, and if it does not, we are left only with possibility. Then there are ideas even stranger, that space itself may be looped, or that our 3 dimensions exist as a surface on a higher dimensional space, that the beyond isn't outward but inward, curled into dimensions we cannot perceive, or that the universe is a simulation, a pattern of information unfolding on a structure more fundamental than space or time. These are not answers, they are invitations. Invitations to imagine without needing to conclude. Because sometimes the purpose of a question is not to be solved, but to keep us open, to keep us listening, to remind us that wonder is more durable than certainty. So what lies beyond? It might be more stars, it might be different physics, it might be nothing, it might be something so unlike anything we can conceive that even the word beyond fails to point toward it. Or it might be a kind of limit to questioning itself, not a wall in space, but a wall in thought, where the only honest thing left to say is, we don't know. And that's okay, because not knowing is not a weakness. It is a kind of strength. The strength to live in a universe that is still being written, still unfolding, still far stranger than we ever imagined. To live in a cosmos where the map is not complete and never will be. That's what lies beyond. Not a place, not an answer, but the quiet awareness that we're already inside something vast and strange and incomplete and beautiful precisely because it is unfinished. Somewhere along the way, as we've wandered gently from the core of galaxies to the fading echo of distant stars, we've encountered a curious idea again and again. The edge of what we can see, the edge of what we can reach, the edge of time, of light, of understanding. And maybe without realizing it, we started thinking of that edge as something fixed, like a fence or a border or a wall. But it isn't. The universe, as far as we can tell, has no edge in the way we usually imagine. No final brick in a cosmic wall. No edge where stars fall off into nothing. What we call the edge is not a place at all. It's a limit of relationship. A horizon shaped not by space alone, but by the dance between time, expansion, and light. And a horizon is different from a wall. A wall stops you. It says, no farther. A horizon invites you. It says, look. It's always ahead, always just out of reach, but never refusing you the wonder of trying to see more. That's what the edge of the universe is like. It moves, it stretches, it changes with time. Not because it's fleeing, but because it's defined by what we can know. And knowledge, like light, has a speed limit. The farther you go, the more you discover that seeing and touching are not the same. You might observe a distant galaxy. You might even understand it, but you cannot reach it. Not because of how far it is, but because of how fast the space between you expands. So we live inside a moving horizon, a bubble of visibility. And for each of us that bubble is slightly different. Because you're not standing at the centre of the universe, but you're standing at the centre of your observable universe. That's a lovely thought, really. In a cosmos with no special location, you are still surrounded by everything you can. See everything you've ever seen. The light reaching you now began its journey just for you. And in that sense, you're always in the middle of your own story. A story written in photons and gravity, carried across billions of years, just to fall gently into your eyes. And if we stretch the idea further, maybe the most unreachable edge isn't spatial at all. Maybe it's time, because time too has a horizon. There are things we can no longer remember, moments that have passed beyond recall. There are also futures we cannot visit, even in our most hopeful calculations. Time is always slipping away, always expanding behind and ahead of us. And the faster we try to hold on to it, the faster it seems to dissolve. We talk about the future as if it were a place, something just down the road. But the future is more like a fog. It reveals itself slowly, and never all at once. You move through it without even trying, and all around you the light shifts, just enough to remind you. You're still moving. You're still here. And this matters. Because the edge, whatever kind you mean, is not just a feature of the cosmos. It's a part of being human. We're always brushing against limits. The edge of what we can understand. The edge of what we can express. The edge of what we can carry or release or forgive. And maybe the most honest way to live is not to fight those edges, but to acknowledge them, to meet them not with resistance but with attention, to pause at the threshold and say, I don't know what lies beyond this, but I know that I am here now, and that's enough. The cosmos does not offer conclusions, it offers continuity, it offers the ongoing presence of mystery, and in that mystery we are allowed to find peace. You're not meant to reach every galaxy, you're not meant to answer every question, you're meant to listen, to wonder, to drift gently along the horizon of the known, and occasionally beautifully, or to see a little further than you did before. That is not a wall, that is a gift. And so, as the stars spin slowly overhead, and the edge recedes just a little farther into the dark, you remain, not waiting, not lost, simply here, in the middle of the universe, and also, somehow, right at the edge of it all. You've been travelling for quite some time now, not through space, not in the physical sense, but across an immense, invisible map of thought. One where galaxies drift like lanterns in the dark, and time folds softly into the background. And after all this wandering, all these stars and distances, all these curves and limits, you find yourself here. Not at the end, but at the beginning of something else. A quiet, a stillness, a return. Because in the end, the question of the universe's edge isn't about space, it's about perspective. And from here, in this moment, at this hour of night, it's enough just to rest in the knowledge that you're part of it. A small voyager nestled gently in a story too vast to ever be told in full. You were never expected to understand everything. You were never asked to reach the edge. You were simply invited to wonder. And you did. You listened. You imagined. You let your thoughts drift past quasars and redshift, entropy and curvature. You walked, in your mind, to the edge of what light can reach, and still you kept going. That in itself is beautiful. Not because it gives you answers, but because it teaches you to ask without needing them. The universe is not a puzzle with missing pieces. It's a canvas that keeps unfolding the longer you look. And you're not just watching it. You're made from it. Every atom in your body was forged in stars that burned billions of years before the Earth was born. Your breath carries particles that once floated in distant nebulae. Your heartbeat is driven by processes that echo the first fires of creation. You are, quite literally, stardust in a sea of silence, a brief flicker of consciousness in a timeline older than words. But in that flicker, so much can happen. A thought, a kindness, a question whispered into the dark, a moment like this. And maybe that's what edges are really for. Not to keep us out, but to give us something to lean against. A place where curiosity slows and wonder takes its turn. A soft boundary between what we know and what we can imagine. There will always be more. More stars, more distances, more futures we cannot yet name. There will always be galaxies beyond sight, questions without answers, and stories that no one will ever hear. But tonight, none of that needs to trouble you. You are not missing anything. You're not behind. You're not late to some cosmic revelation. You're exactly where you belong, suspended in space and time, in a little moment that belongs only to you. Let the galaxies drift. Let the stars cool. Let the universe expand without permission. You do not have to hold it all. Just breathe. Let the vastness become softness. Let the science become silence. Let the edge, wherever it may be, dissolve gently into a dream. The questions can wait. The wondering can pause. And the stars, old as they are, will keep watch. Sleep well, small voyager. You've travelled far enough for one night.